Now, before looking at the finally keyword, let's look at some code. Okay, to take a look at how multiple catch blocks actually work. You want to trace the flow. Okay, this is the same test class with a main method. Okay, I'm going to modify it a bit. So instead of entering only one number, I'm going to prompt the user to enter two numbers. Enter a second number, and the second number is going to be called input string 2. It's going to be stored as a string. Alright, input 2 equals to 0, and I'm going to have a third variable called quotient. So I'm going to find out the input 1 divided by input 2 and store the answer in quotient. Alright, I'm dealing with integer division here. So in a try block, okay, I'm going to try to convert both input string 1 and input string 2 into input 1 and input 2. I'm going to print out some checkpoint statements here, x, w, x, y. Alright. And then I'm going to do something like quotient equals to input 1 over input 2. Alright. And here I'm going to print out your quotient is quotient. Okay. I'm going to have two catch blocks. The second catch block is going to catch for arithmetic exception. Arithmetic. How do I spell that? Oh goodness. There is one exception class called arithmetic exception. Just pardon my pronunciation. Here it is. Okay, and it is thrown when a division by 0 occurs. Okay, perfect spelling. The second number must not be 0. Okay, let's look at our code now. We have got a try block, okay, which does a few things. Oh, I forgot to insert another checkpoint printout. WXYZ. Okay. We have a try block and we have two catch blocks associated with the same try block. Now the first catch block catches a number format exception, and that may be caused by line 20 or line 22. Okay. Now the second catch block catches an arithmetic exception, which may be caused by line 24. It happens when input 2 is 0. If you perform a integral division by 0, okay, you will get an arithmetic exception caused by that division the operation. Okay, this does not apply when you try to divide a double with a double or a float with a float. Only happens with integer divided by integer, and the denominator is 0. Okay, let's save this and let's try to do some code tracing. Compile test.java. Let's run it. Now for the first run, let's do everything nicely, no exceptions. Okay, enter a number, enter 10, enter second number 2, and you print out, your quotient is 5, which is 10 divided by 2. Let's trace through. The program starts, I go on to line 18, line 19, and I print out checkpoint W. It's exactly what is printed out here. I go to line 20, okay, no exceptions there. Input 1 will store the number 10. I go to line 21 and print out checkpoint X here. I go to line 22, no exception here. Input 2 will store the value 2, okay, as a number. I move on to line 23, which prints checkpoint Y. Line 24, which will store 5 in the variable quotient. Go to line 25, print checkpoint Z. Skip the two catch blocks. Alright, totally. Go to line 34 and print out your quotient is something. Okay, this is the first case, no problems. Now let's trace through when something goes wrong. First number is 6, second number is A. Alright, that caused an exception, a number format exception in this case. Program starts, program goes to line 19, line 20, 21, 22, and line 22 causes a number format exception because I'm trying to convert A into an int. Alright, line 23 is skipped, that's why in the output you don't see, checkpoint Y or Z. Line 23 is skipped. All subsequent lines, 23, 24, 25, all skipped. And I'll jump from line 22 to the catch block here. Okay, line 27, which catches a number format exception. Prints out error, you have entered an invalid number. Okay, after only one of the catch blocks will run. In this case, if I have 1000 catch blocks associated with the same try block, only one will run. Okay, depending on which exception has been caught. So this one runs, this is ignored. I'll move on to line 34 and prints out your quotient is 0. Okay, because 0 is the default value for quotient. Okay, let me clear the screen and let's try another scenario. This time I enter 8 followed by 0. Okay, let's see what happens. Program runs, I go to line 19, 20, 21, no problem. 22, no problem. 23, okay, you realize that checkpoint Y gets printed out here. Okay, line 24 causes a problem because input 2 is 0. And I get an arithmetic exception thrown here. Line 25 is not executed. Line 25 is skipped, and that's why you don't see an output checkpoint Z. You don't. So from line 24, I jump to the second catch block, okay, which matches the kind of exception caught, thrown. Arithmetic exception, and I print out error. The second number must not be 0. Exactly what we see here. And after the catch block runs, I go on to line 34 and print your quotient is 0. So as long as one of the catch blocks has successfully caught the exception, it is deemed that the exception has been successfully handled, and the program carries on running. That's why line 34 continues as normal. Right? Okay, so we have seen an example of multiple catch blocks. Okay, only one of the multiple catch blocks associated with the same try block will run. Let's talk about finally. Now there are 3 ways to do try and catch. The first way, okay, we have seen it, one catch block, or you can have multiple catch blocks, okay, times n. You can 1 or 2 or 3 catch blocks associated with the same try block. A second way to use try and catch is to include a finally block. Alright, that's the way to do it. Try, catch, any number of catches. 1, 2, 3, I don't care. N times catch blocks. The last block is finally. Alright, and the third way to use try is you have a try block and you have a finally block. That's it. You do not have any catch blocks. Now this third configuration may not be that common, but there is some use for this. Okay, in this case, you want to run some code in the finally block before returning. Okay, before throwing the exception back to the caller. Okay, we'll see this very soon. Now let's examine this. What is the finally block? Now the finally block is a place where you put code that will run regardless of whether an exception occurs or not. Let's go back to the same example. I'm going to include a finally block here. Finally, you can have only one finally block, unlike catch blocks. Finally, system.out.println running finally block. Okay, save it, compile. Okay, let me say again. I was saying the finally block will run regardless of whether an exception occurs or not. So let me demonstrate this. Enter number 8, enter number 4. Okay, in this case, no exception has occurred. All the statements in the try block will execute all the way to line 25. Okay, line 25 will print this out. After line 25, the first catch block is skipped, the second catch block is skipped, but I will go into the finally block and run the statements there. Line 34 will print this. Okay, finally, after the finally block, I'll go on to line 37 and print this. So first scenario, no exception. After the try block finishes, the finally block runs. Second case, what happens when there is an exception? Let's try 9 and 0. So line 19 runs, line 20, 21, 22, 23, 24 is the one which causes an exception because I'm doing a division by 0, and that's why you see checkpoint Y printed here. Checkpoint Y is on line 23. On line 24, exception occurs. I'm going to skip line 25. Okay, where is the exception caught? It will be caught in the second catch block. Alright, so line 31 will run and it prints this. The second number must not be 0. After the catch block runs, I will run the finally block. And the finally block will print this out, running finally block. And then you have line 37, which prints out your quotient is 0. So the finally block I've shown here very clearly is a place where you should put code, cleanup code. Okay, code which will execute regardless of whether an exception occurs in a try block or not. So people use the finally block, okay, to insert cleanup code. Let me give you an example of a cleanup code. For example, your try block may contain statements which connect to a database and perform some SQL transactions. Okay, and you might have a catch block which catches an SQL exception or whatever. Okay, which deals with a database, some different types of exceptions. Now your finally block in this example may contain code which checks which closes the database connection if it is open. So regardless of whether everything works or if a problem has occurred, I will still want to close the database connection if it is open. I put that code in the finally block. Alright, so use the finally block wisely. Okay, use it to serve you well. And that's all I want to talk about as far as finally is concerned.